Right, guys, let's start with phase, waves and phases. Turn the fan off, please. We have papers flying all over the place. Right, let's get straight into this. We have not more than 20 minutes, so we'll have to get to this straight. And yes, just so the A-level students know, Monmoy is student of the day from our previous video. If that makes him feel a little better, and also with him, two other people got it. It's a joint win by Monmoy plus Washiva plus Tafim Isfar Mustafa. So, good job there. Good job.
But Monmoy for the win.
And one more number first day.
Okay, so let's get into this. So sine theta একটা graph আছে, right? You guys know the y is equal to sine x graph and everything. So the graph kind of looks like this. And the reason I'm talking about sine theta and everything is because when we talk about phase difference in any sort of graph, we usually go along with the trigonometric relevance of it. So this point here, the starting point, is when theta is equal to 0. Theta is equal to 0 degrees. This point is when theta is equal to 90 degrees. This point is when theta is equal to 180 degrees. This point is when theta is equal to 270 degrees. And this point again is theta is equal to 360 degrees. So now the thing is that we will use this map basically to represent different positions of a wave, right? So for example, Boloto, what should this point be in degrees?
45.
Yeah, that's easy stuff right there, 45 degrees, right? What should this point be? I have no clue. Something between 180 and 2. Yes, that's right, it's 225. So basically we're going to be using this to represent different positions of a wave. So phase is basically the difference between waves, 2 points on the same wave, for example. Say I take this point here. Okay, that's too light. Let's take this. Say I take this point here and I take this point, right? So what's the phase difference between these 2 points? So what's the difference between the 2 points?
415
minus 90, which is 360.
Hey, I was close.
Oh, it's close.
I was just like half off.
Yeah, half off. So, এখন, basically this has a phase difference of 360 degrees. Let's try different points now. Let's take this point and say A point and this point. What's the phase difference between these 2 points? Is it the 2 pink ones?
180.
Eta 180 or eta 360. So what's the phase difference between them?
180.
180, that's right. Easy. Right? You're getting there. Okay, mystery student, I have a question for you. This point and this point, what's the phase difference between these
90.
two? Yeah, that's easy. 90 degrees. So I think you guys get the idea of the phase difference. Now I'm going to just ask you the same things, but in path difference. Now let's try something a little different. Let's represent differences according to path difference, right? So if we talk about path difference, this whole path is how much? Lambda, right? So in terms of lambda, this is how much? Half lambda. Excellent. How much is this? Whole lambda. This is?
1/4.
1/4. This is?
3/4.
3/4. Okay, so we have the idea. So now if I start drawing a wave on top of this, which has, say, 1/4 lambda path difference.
1/4 lambda difference.
Yeah.
Okay.
That would basically mean I'd start from here.
Would you
Right.
end at 3/4 lambda?
Depends where I end. Doesn't necessarily have to be a value. Basically, it would be something like this, right? These two graphs or these two waves have a path difference of 1/4 lambda.
So when we're saying path difference, when we're starting.
We talk about it in lambda.
Oh, so
We
starting
state
from
it in lambda.
Okay.
Oh, okay.
And also we start from the beginning.
It doesn't necessarily have to be the beginning. I'm at 8 point, 2 point over the path difference is still 1/4 lambda, right? Now here's an interesting thing. 1/4 lambda, if we were to represent it in phase, how much would that be?
So that's
90.
9.
90, yes? Now here's the interesting thing.
Hey, you had to look.
Hey, come on, man, I'm looking at this. So 1/4 lambda and 90 degrees is basically 1/4 of the wave cycle, which is 360. So you could say that the wave difference here is basically 1/4. If you multiply it with lambda, say the wavelength is, let's just give it a random value, 5 centimeters, right? So how much is the actual distance between these 2 points? Or actually the path difference between these two waves.
Isn't it just 1/4?
It's basically 1/4 of 5 because lambda is 5 centimeters. So it would be 1.25 centimeters. And if we talk about 1/4 of it in degrees, then it's basically 90 degrees. We can even take this concept and go into radian. For example, if one complete cycle is 2 pi, then how much is 1/4 of 2 pi? Right? Which is basically pi by 2. So this is how we can also represent phase difference. Right? Is this making sense? Is this making sense, guys? Right, good. Now, let's move on and let me tell you about something a little more complicated. So, this wave, let's give it a phase difference. Let's draw another wave on it with a phase difference of 60 degrees.
Oof. Okay.
Okay? 60 degrees. So, how much do you think that would be of the entire length?
1/6.
Excellent. This guy is smart because if it's 60 divided by 360, 1/6. So 1/6 of lambda. Okay, shut up. So basically, what we get is this. So where would 1/6 of the wave technically be?
1/6 of the wave.
Yes, say it's going to be somewhere around here.
45.
All right. So if I draw it from here, it would be something like this. So these two waves have a phase difference of 60 degrees. And if I was to talk about path difference, they would have a path difference of 1/6 lambda. Right? I guess this kind of makes the stuff pretty easy and straightforward to understand. There isn't much of a complication here. Now, let's move on to something a little more complicated when it comes to phase and everything. We need to talk about path difference. All right? So, say I draw a wave like this, and this wave has a certain length. Say this is 15 centimeters. Whoops. 15 centimeters. Right?
Okay.
And so, say there's this metal surface. This is a metal surface. So it would reflect waves which are electromagnetic waves. So say this is a microwave, right? So we have a source of microwaves and it travels from this direction and it bumps into this wall and then it bumps back here. And we take another wave which travels straight from here to here, right? So there's two paths. Now, let's give the values of these paths. Say this is 45 centimeters, right?
Okay.
And say this is 30 centimeters. What?
Nice jump.
What?
I have no idea what's happening.
Well, nothing's happening yet. Calm down, like, you know. Oh, yeah, we could do the welcome to AS. All right. And say this length is 97.5 centimeters. Calm down.
Language, man.
Sorry.
Calm down, man. Don't use bad words on live. Like, you know, people will hurt, it will hurt their feelings.
Little kids, listen.
Little kids, yeah, sure. Marks, like, you know. Anyway, so now, now the question is, we have two waves traveling, one along this direction and another along this direction. When they meet here, what would be their path difference? Right?
Okay.
This is pretty easy. This is 45 centimeters, so a wave traveling along this, and then it comes back to here. So the total path difference, or the total path that this route has, is 45 plus 30, which is koto?
70.
75.
Sorry,
75 centimeters. And this is already written as 97.5 centimeters. So how much is 97.5 minus 75 centimeters?
22.4.
Yeah, that's right, 22.5 centimeters. Quick math. Now, here's the tricky bit. If the wavelength is 15 centimeters, how much is this difference in terms of lambda?
Ulta divided by 15.
Yeah, you guys are good at this. 15 centimeters, which is basically 1.5 lambda. Right?
Man,
Given our
special, man.
quick math is correct, these waves are meeting here with a path difference of 1.5 lambda. So if you have a path difference of 1.5 lambda, what phase difference will it lead to?
Does a path difference of 1.5 lambda mean initial টা যদি lambda হয় second টা 1.5 lambda path difference travel করতেছে?
Yeah, initial টা যদি 1 হয় তাহলে the other one is reaching at 2.5. There's always going to be a difference of 1.
Addition. Okay.
If it's at 0, then the other one's going to be at 1. If it's 0.5, the other one's going to reach at 2. So basically, the easiest thing we can do is just we take the coefficient of the path difference lambda, 1.5, and you multiply it with 360. Right? So I can write this as 360 plus 180. The reason I'm breaking this down into two separate values is to show that the whole cycle is done and then we have another half cycle. So a full cycle and a half cycle, which leads to this. All right. So basically the phase difference of 180 degrees leads to what? Destructive interference. Why? Because whenever waves meet with a phase difference of 180 degrees, it always leads to destructive interference. Is this clear?
Yes.
Okay.
Sure, 180 becomes 0.5. 180 becomes 0.5.
Yes, the 0.5 lambda, if you multiply 0.5 with 360, you end up getting 180. And that's basically why we have this thing going on. All right. So this is one example of path difference, all right? And these are different examples of phase difference, right? So now let's try another question. See if you guys can do this. Whoever can do this first. So say this wave has a wavelength of, the green one has a wavelength of 90 centimeters, right? And say this also has 90 centimeters, obviously. And this distance is 30 centimeters, right? Okay. So if these waves were to meet, what would be the phase difference between these two waves? 120 degrees. And 120 degrees is the answer. Well, easy. 90 centimeters to the wavelength. How much is 30 centimeters of 90? It's 1/3.
Yeah.
So 30 divided by 90 is equal to 1/3. And this is the ratio between the waves. Now just multiply this with 360. So 1/3 into 360 is going to give you the phase difference, which is basically 120 degrees. এটা দেখো না দুমদাম 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 সবাই আনসার করে ফেলাইতেছে ঠিক আছে Nice, good job guys, good job, I'm proud of you guys. All right, one last question, then we're going to wrap up for tonight. We'll have to talk about interference soon after this. Okay, this is going to be the last question. So this is two waves at time t. Okay, so this time, let's say this time is 12 seconds, right? Yeah. And we can see a very visible phase difference between these two waves, right? By the time it reaches here.
Okay.
This looks like a literal wave.
Anyway, so whatever. So এখন, the question is, what is the phase difference? Yeah. At 4 seconds. All right, guys, let me tell you now. Moment of truth. So this is one cycle, this is 2 cycles, this is 3 cycles. So this path is basically 3 cycles, right? This is 1 cycle, this is 2 cycles, and this is another half cycle. So 2.5 cycles.
I thought it ended there.
Oh my god.
What do you mean it ended there? It ended here.
Fine.
None of that. None of that. So 12 seconds পরে ওদের difference হয়েছে 180 degrees. তাই না?
Plus 0.5.
Because half a cycle. Half a cycle is 180 degrees, right? Does everyone get this much?
Yeah.
So now, if 12 seconds causes 180 degrees, at 0 seconds they were in phase, right? That's what our diagram is showing. So at half the time it would have been at 90. Right? Nashlian? মানে আস্তে আস্তে 0 থেকে the phase difference increased as it went along.
Yes.
Phase difference বাড়তে বাড়তে reached 180 after 12 seconds. So if it was at 6 seconds, you would have seen a phase difference of 90 degrees. So at 4 seconds, how much would you see? You would see 4/12, which is basically 1/3. You'd see 1/3 of 180 degrees. Because it's 1/3 the time through. So your answer is actually 60 degrees.
Can you ball me 60?
Samin bolchilo, but then he changed it to 180 and then changed it again to 90.
That doesn't count.
No, it won't count. It will not count.
What if he deletes the comments?
Screenshot. It's a 60 degree. It's a Praman. But he has good try, Samin. I'd say he's the closest. Samin Sabah said 90 and Masur bin Mahbub, Samin Rahman, F. Yes, guys, press F to pay respects to our fallen Samin, who went all the way to 60 to 90 and then 180. Yes, I feel bad for you, but we need to stick to the rules.
Wow, what is this?
You weren't there.
Yeah, you weren't there. You wouldn't know. All right, guys. I think we're done. Atske, we're going to keep it here because we need to start A2s. Kalke, we're going to talk about wave interference, all right? Constructive, destructive interference. And we're going to go into, from there, standing waves and other stuff. All right, then, guys, we're done for tonight. Thank you. And most especially, thank you to Samin Rahman for your very, very creative cat. And also, thanks to everyone else who tried to give the answers. And press F for showing respects to Fallen Soldier. All right, then, guys. Good night. Take care. And if you have any questions or queries, or if you have any questions from the papers that you need to get solved, just send them as pictures to us on our group. We'll try to come up with the best answers and send them to you.
Page.
Yes, RT page. Sorry, send it to the page, RT page.